Welcome to Junior High School Math Series. In this presentation, let us talk about permutation. Permutation is the arrangement of all or part of a number of things where order is important. The most common example given when it comes to permutation of objects is the arrangement of the letters A, B, and C. ABC is one of the arrangement, and ACB is another. Also, BAC is an arrangement different from the first two. AB and C can also be arranged in BCA, CAB, and CBA, making it a total of 6 possible arrangements of letters A, B, and C. The number of arrangement of n distinct objects, taking n objects at a time, is given by the formula n permutation n is equal to n factorial. It can also be written in the form permutation of n taken n is equal to n factorial. Let us have example number 1. How many ways can 5 pupils fall in line? Here is our suggested solution. From the given information, there are 5 pupils who will be arranged in a linear formation. Therefore, order is important. Using the formula for the number of arrangement of n objects, taking n objects at a time, we have 5 taken 5, or 5 permutation 5 is equal to 5 factorial. From the definition of a factorial, we multiply the integers from 5 down to 1. So we have 5 times 4 times 3 times 2 times 1, and this is equal to 120. Therefore, 5 pupils can fall in line in 120 different ways. Let us have another suggested solution for example number 1. Using the fundamental principle of counting, let us consider 5 line spaces that the 5 students can take during the arrangement. Arranging 5 students in a line is a task that can be broken into 5 consecutive steps. Step 1 can be done in 5 different ways since there are 5 pupils in the pool to choose from. Step 2 can be done in 4 different ways since there are 4 students left. Then step 3 can be done in 3 different ways. Step 4 can be done in 2, and since there is 1 student left in the pool, step 5 can be done in 1 way. Notice that these steps are consecutive and cannot be done all together at once. Hence, by multiplication principle, we have 5 times 4 times 3 times 2 times 1, and that is equal to 120. 5 pupils can fall in line in 120 different ways. Let us have example number 2. In how many ways can 7 students be seated in a row if 2 particular students would like to be seated next to each other? Here's our suggested solution. From the given information, we have 7 students, and 2 of these students would like to sit next to each other in the arrangement. In this case, the 2 students will be together in whatever arrangement we may have. Therefore, it's like we are just arranging 6 students in a line. So we have 6 permutation 6. The 2 students who are always together may still interchange the position, so that will be 2 permutation 2, and by multiplication principle, we multiply 6 permutation 6 by 2 permutation 2. Hence, we have 6 factorial times 2 factorial. And 6 factorial is the product of the integers from 6 down to 1. Also, 2 factorial is the product 2 times 1. Then we have 1,440. 7 students can be arranged in 1,440 different ways if 2 students would like to sit next to each other. When the task is to create a linear arrangement of r number of objects from a pool of n number of objects, then the permutation of n different objects taking r objects at a time is given by n taken r is equal to n factorial over n minus r factorial. In here, n and r are non-negative integers and r is less than n. Let us have an example. Evaluate 12 permutation 4. Here's our suggested solution. From the given information, n is equal to 12 and r is equal to 4. So we have 12 taken 4 is equal to 12 factorial over 12 minus 4 factorial. To evaluate this, we rewrite 12 factorial into the product 12 times 11 times 10 times 9, and there's no need to write it down to 1 because there is a 12 minus 4 that is equal to 8 factorial in the denominator. So we stop at 8 factorial in the numerator. Anyway, when we evaluate further, 8 factorial over 8 factorial is equal to 1. So we have 12 times 11 times 10 times 9, and that is 11,880. 12 permutation 4 is equal to 11,880. Example number 4, find the value of n if n plus 2 permutation 2 is equal to 5 times n minus 1 permutation 2. Here is our suggested solution. From the formula for permutation n taken r, n plus 2 permutation 2 is equal to n plus 2 factorial over n plus 2 minus 2 factorial. Also, n minus 1 permutation 2, by formula, we have n minus 1 factorial over n minus 1 minus 2 factorial. N plus 2 minus 2 is equal to n. So in the denominator, on the left-hand side, we have n factorial. N minus 1 minus 2 is n minus 3. So we have n minus 3 factorial in the denominator on the right-hand side. N plus 2 factorial can be written as n plus 2 times n plus 2 minus 1, and that is n plus 1, times n plus 1 minus 1, that is n factorial. We stop at n factorial because in the denominator there is n factorial. On the right hand side, we have n minus 1 times n minus 1 minus 1, and that is n minus 2, times n minus 2 minus 1, and that is n minus 3 factorial. Notice that in the denominator we have n minus 3 factorial, so we can cancel that out when we evaluate this further as n minus 3 factorial over n minus 3 factorial is equal to 1. Now, n factorial over n factorial is equal to 1. Also, n minus 3 factorial over n minus 3 factorial is equal to 1. So we have n plus 2 times n plus 1 on the left-hand side, and that is n squared plus 3n plus 2. On the right-hand side, we have n minus 1 times n minus 2, and n minus 1 times n minus 2 is n squared minus 3n plus 2. By distributive property, we have 5n squared minus 15n plus 10 on the right-hand side. The equation is now a quadratic equation. So to solve for the variable n, we rewrite this in its general form where the right-hand side is 0. So we have 4n squared minus 18n plus 8 is equal to 0. Dividing all terms by 2, we get 2n squared minus 9n plus 4 equals 0. This quadratic equation is factorable, so we extract the roots using factoring. 2n minus 1 times n minus 4. To get the value of n, we equate each factor to 0, and we will get n is equal to 1/2 from the first factor, n is equal to 4 from the second factor. Going back to our given, n must be a positive integer. Therefore, we can only accept n is equal to 4 as our final answer. Let us have example number 5. In how many ways can the letter of the word number be arranged taking 3 letters at a time? Here is our suggested solution. The word number has 6 letters, N, U, M, B, E, R. Then N is equal to 6 and R is equal to 3. Using the formula, we have 6 taken 3 is equal to 6 factorial over 6 minus 3 factorial. By the definition of factorial, we rewrite 6 factorial as 6 times 5 times 4 times 3 factorial. We stop at 3 factorial because the denominator is 6 minus 3 factorial, and that is also 3 factorial. 3 factorial over 3 factorial is equal to 1. Then 6 times 5 times 4 is equal to 120. So the letters of the word number can be arranged in 120 different ways, taking 3 letters at a time. This time, let us have permutations when certain objects are repeated. If a set of n objects contains p identical items, q identical items, r identical items, and etc., are arranged in a row, the number of arrangements is equal to n factorial over p factorial times q factorial times r factorial, and so on, depending on the number of items that we have. Let us have example number 6. In how many ways can the letter of the word statistics be arranged? Here is our suggested solution. The word statistics has 10 letters with 3 S, 3 T's, and 2 I's. Hence, n is equal to 10, so we have 10 factorial over 3 factorial, that is for the 3s, times 3 factorial, that is for the 3t's, times 2 factorial, that will be for 2i's. Evaluating this further, we write 10 factorial as the product, 10 times 9 times 8 times 7 times 6 times 5 times 4, until 3 factorial because we have a 3 factorial in the denominator. However, the other 3 factorial must be expanded as 3 times 2 times 1, and also 2 factorial is 2 times 1. This time, we can cancel some values. 3 factorial over 3 factorial is 1. 3 times 2 is 6, so we can cancel 6 in the numerator. That is 6 over 6 is equal to 1. Also, we have 2 in the denominator left, and 4 can be reduced to 2, as 4 divided by 2 is equal to 2. Then we have 10 times 9 times 8 times 7 times 5 times 2, and that is equal to 50,400. Therefore, the letters of the word statistics can be arranged in 50,400 different ways. This time, let us have circular permutation. The number of circular permutation of n distinct objects when clockwise and anti-clockwise orders are different is given by n minus 1 factorial. Let us have example number 7. In how many ways can 8 persons be seated at a round table? Notice that arranging 8 persons in a round table will have different orders in clockwise and anti-clockwise arrangements. Hence, we use n minus 1 factorial. Here is our suggested solution. From the given information, n is equal to 8. Therefore, we have 8 minus 1 factorial. 8 minus 1 is 7. By definition of factorial, 7 factorial is the product from 7 down to 1. So we have 7 times 6 times 5 times 4 times 3 times 2 times 1. And that is equal to 5,040. Therefore, 8 persons can be seated 5,040 different ways at a round table. The number of circular permutation of n distinct objects when clockwise and anti-clockwise order are taken as not different. we have n minus 1 factorial over 2. Let us have example number 8. In how many ways can 12 beads be arranged in a circular bracelet? Here is our suggested solution. Since arranging 12 beads in a circular bracelet, the clockwise and anticlockwise orders of beads are the same. Hence, we use the n minus 1 factorial over 2 formula. And from the given information, n is equal to 12, so we have 12 minus 1 factorial over 2. 12 minus 1 is 11, so we have 11 factorial over 2, and that is equal to 19,958,400 ways. 12 beads can be arranged in a circular bracelet, 19,958,400 different ways. The number of circular permutation of n distinct objects taken are at a time when clockwise and anticlockwise orders are taken as different. We use the formula P is equal to n permutation R over R. In how many ways can 5 spotlights of different colors be arranged in a circle from a set of 10 spotlights with different colors? Here's our suggested solution. Since in arranging 5 spotlights in a circle, the clockwise and anticlockwise orders are different, and we take these 5 from a group of 10 different spotlights, hence we have n is equal to 10 and r is equal to 5, so we use the formula n taken r over r, so we have 10 permutation 5 over 5. 10 permutation 5 is 10 factorial over 5 factorial divided by 5, so we have 10 factorial over 5 factorial times 5, and this is equal to 6,048. Therefore, 5 spotlights of different colors can be arranged in a circle from 10 different spotlights, 6,048 ways. The number of circular permutation of n distinct objects taken are at a time when clockwise and anticlockwise orders are taken as not different. This is given by n taken r over 2r. Let us have example number 10. In how many necklaces of 10 beads each can be made from 16 beads of different colors? Here's our suggested solution. Since arranging 10 beads in a circular bracelet, the clockwise and anticlockwise orders of beads are the same, and we take these 10 beads from a set of 16 beads. N is equal to 16 and R is equal to 10, and we use the formula N taken R over 2R. So we have 16 permutation 10 over 2 times 10. 16 permutation 10 is 16 factorial over 6 factorial. That is divided by 2 times 10. So we have 16 factorial over 6 factorial times 20. And this is equal to 1,452,971,520 necklaces of 10 beads each can be made from 16 beads of different colors. That will be all. Thank you for watching. Please subscribe for more math lessons.